Boys and girls, how are you? I know that all of you are fine and healthy. Keep studying at your home. Boys and girls, I'm going to start a new lecture on the basis of physics second paper. On the basis of chapter number 5, and you know that the name of chapter number 5 is electromagnetic induction and AC current. And my today's topic, I'm going to solve creative question on the basis of this chapter. I repeat, boys and girls, I'm going to solve creative question on the basis of this chapter. The stem of my today's question. An equation of AC current is given below. It is I equal to 10 sine 100 pi into t ampere. 10 sine 100 pi into t ampere. On the basis of this stem, we are going to solve the following questions. Question number A. What is called AC current? Now question number B is a very familiar question. Why 220 volt AC current is more dangerous than 220 volt DC current? I repeat, boys and girls, why 220 volt AC current is more dangerous than 220 volt DC current? Now boys and girls, question number C, find out required time for this AC current to reach from 0 to peak value. To reach from 0 to peak value. And question number D, if this AC current is connected with 100 ohm resistance, then will it produce here 5000 joule per second heat? Will it produce 5000 joule per second heat? Explain mathematically. Boys and girls, on the basis of my previous lecture, I just discussed about the different properties of AC current. Okay, so on the basis of this property, you can explain the definition of AC current very easily. So what is AC current? You can say that the electric current which can change its direction with respect to time is called AC current. The another name of AC current are number 1, alternating current, number 2, periodic current. Number 1, alternating current, number 2, periodic current. Now, boys and girls, I'm going to solve question number B. In question number B, it is why 220 volt AC current is more dangerous than 220 volt DC current. If I say that, boys and girls, 220 volt DC current, then it can say that the voltage of DC current E for the case of DC, it will equal to obviously 220 volt. It is fixed. It is fixed. Okay. But when you say that, sir, it is 220 volt AC current, you must say that the graphical presentation of AC current is just like this. The presentation of AC current is just like this. Okay. This axis indicate time, and this axis indicate AC voltage. You know that this AC voltage has a maximum or peak value, and this peak value is denoted by E naught. This peak value or maximum value is denoted by E naught equal to maximum value or peak value. You know that this given 220 volt AC current indicate that is the effective voltage or is the RMS voltage. So effective voltage or RMS voltage of this AC current will equal to 220 volt. Now I'm going to find out what's the value of its peak value E naught. What's the value of its peak value E naught? So you see that its peak value E naught will equal to 0.707 E naught. 0.707 E naught. And it will equal to here 220. It will equal to here what? Here 220. Now, if I'm going to find out the value of E naught, this E naught will equal to 220 divided by 0.707 volt. Will equal to what? Will equal to, you can say here, it will equal to 220 divided by 0.707 is nothing but 311.2 volt. 311.2 volt. So you see this, the value of AC current is fixed, DC current is fixed. It is only 220 volts, but the value of AC current varies, having 220 volt varies from 0 volt to 311 volt. Since its value varies continuously with respect to time and its maximum value is 311 volt, at peak point it can give a shock of equivalent voltage will equal to 311.2 voltage. That's why we can say that the same voltage or the 220 volt DC current, okay, is less dangerous than that of 220 volt AC current. Or you can also say that in other words, it is 220 volt AC current is more dangerous than 220 volt DC current. I repeat, boys and girls, 220 volt AC current is more dangerous than 220 volt here DC current. So on the basis of this lecture, I think you can explain the question number B. This is a very important question of this chapter. Now, boys and girls, I'm going to solve question number C. You see, find out the required time for AC current to reach from 0 volt to peak value. Okay, from 0 to peak value. Now, to solve question number C, at first I need to draw the AC current. You know that the AC current is just like this. This is the AC current. This is the AC current. This time axis, and this is AC current axis. Its peak value will equal to I naught. Its peak value will equal to I naught. Okay? It said that after how long it will take from 0 value to peak value. Suppose this is 0 and this is point A. And I'm going to find out the required time T to reach at point A. The required time T to reach at point A. So to find out this time, I need to know about the time period of this AC current or frequency of this AC current. So let's see how can I find out this. You know that the equation of AC current, it is I equal to 10 sine then 100 pi into T. 10 sine 100 pi into T. This is a given equation. Now, to find out its different property, you have to compare this equation with the standard value of equation. Boys and girls, you need to compare this equation with the standard value of equation. And you know that the standard value of equation I will equal to I naught sine omega into T. I will equal to what? I will equal to here I naught sine omega into T. Now, I naught equal to, what is the value of I naught? I naught equal to 10 ampere. So I can say that I naught will equal to 10 ampere. If you compare these two equations, then you can say that I naught equal to 10 ampere. So this is the peak value of AC current. This is what? The peak value of AC current. Okay? This is the peak value or maximum value of AC current is nothing but 10 ampere. Now, if you compare this to equation, then what is the value of angular frequency omega? You must say that sir, omega will equal to 100 pi. Since omega will equal to 100 pi, I'm going to find out its time period. You know that omega equal to twice pi divided by capital T will equal to 100 pi. Will equal to what? It will equal to here 100 pi. Now pi will cancel out from both sides. So 2 divided by T will equal to 100. So what is the value of T? If you cross multiply here, it will equal to 2 divided by 100 will equal to 0.02 second time. Is the time period of this AC current. Do you know what is the value of time period? Time period is the required time to execute a complete oscillation. I repeat, boys and girls, time period is the required time to execute a complete oscillation. So, to execute a complete oscillation, the required time will be equal to time period. A complete oscillation means what? A complete cycle. You know that this is the half cycle and this is the half cycle. So, the required time from here to this particular point, the time will be equal to time period. Here to this particular time will be equal to time period. And if I convert this time period into time small time t, okay, then I can say that it will be equal to 1 time period, 2 time period, 1 small t, 2 small t, 3 small t, and 4 small t. I repeat again, small t equal to what? Small t equal to is the limiting time to reach this AC current from 0 volt to peak value. To reach AC current from 0 volt to peak value. Since this is the required time to reach AC current from 0 volt to peak value. Now see that this time period capital T can contain 4 small t. One is here, 1 small t, here 1 small t, another is here small t, another is here small t, and last one is here small t. Last one is here small t. So it can contain this 4 small t. So time period can contain this 4 small t. So I can say that this time period t will equal to 4 into small t. Now, what is the value of small t? Small t will equal to capital T divided by 4 will equal to 0.02 by 4 is nothing but 0.02 by 4 will equal to 0. It will equal to here 5 into 10 to the power minus 3 second time. So after this particular time, small t equal to what? Small t equal to 5 into 10 to the power minus 3 second time. This AC current will reach its peak value from 0. This AC current will reach peak value. What does it mean? It means here 10 ampere current from 0. It will take here 5 into 10 to the power minus 3 second time. We take here what? 5 into 10 to the power minus 3 second time. So after this particular time, I repeat, boys and girls, after this particular time, it will reach from 0 to peak value. It will reach from 0 to peak value after this particular time. So this is the answer of question number C. It is 5 into 10 to the power minus 3 second time. It's 5 into 10 to the power minus 3 second time. Now, boys and girls, I'm going to solve question number C. You see here, if AC current is connected, if this AC current is connected with 100 ohm resistance, then will it produce 5000 joule per second heat? Okay, now let's see how can I solve this. At first, I'm going to find out the effective value of this AC current. I repeat, the effective value of this AC current. You see that this AC current, number D, has equation I equal to, it is 10 sine 100 pi into T ampere. So, this AC current has a peak value I naught equal to 10 ampere. We got this from question number C. From answer number C, it will equal to 10 ampere. Now, if I'm going to find out the effective value of this AC current, then I can say that the RMS value or effective value of AC current will equal to 0.707 I naught. So you see that here, 0 point here, it is 707. I naught will equal to 10 ampere. It's nothing but 7.07 ampere. This is the RMS value or effective value of this AC current. Okay, RMS value of effective value of this AC current. Now, by using this current and this given resistance, I need to find out. I'm going to find out its power because it's you're going to justify that it can produce 5,000 joule per second heat or not. This is a power. Joule per second is nothing but power. So you know that there are different formula to calculate power. So power P will equal to what? Will equal to I into R. You know that very well. Will equal to V squared by R. Will equal to VI will equal to I square into R. So these are the three options. How can you calculate power? These are three options here. Okay. So I think this is not the applicable formula because in this math there is no electromotive forces given. So this is not the applicable formula. V square by R is also not the applicable formula. So by using which formula are you going to calculate the produced heat or power? I think by using I square into R. So power P will equal to what? Power P will equal to here I square into R. Now I'm going to find out the effective power of this AC current. You know that it is also called I effective current. So it will equal to I square into R. So I can say that it will equal to here I effective current into R. Now current will equal to 7.07 square. And what is the value of R? R will equal to 100 ohm. R will equal to what? 100 ohm. Now, what is the value of total effective power from this given AC current? Total effective power will equal to 7.07 square multiplied by 100. It's nothing but what? It's nothing but 5,000. It's nothing but here 5,000. Approximately 5,000 watt approximately. So it can produce 5,000 joule per second heat. I repeat, boys and girls. So I think it can produce 5,000 joule per second heat. So you can say that this AC current, if I use with 100 ohm resistance, then obviously we can say that this AC current can produce 5,000 joule per second heat. 5,000 joule per second heat. So the statement of the question is correct. I repeat, boys and girls. So the statement of the question is correct. Now I'm going to conclude this question number D because this conclusion part can carry 1 marks. So from above calculation, we can say that this AC current, if this AC current is connected with if this AC current is connected with 100 ohm resistance, then it can produce 5,000 joule per second heat. So statement of the question was correct. So statement of the question was correct. Now boys and girls, I'm going to give you a homework that you want to solve at your home. So I'm going to erase the left side of my board, this part of my board. So your homework, you're going to solve a similar type of question at your home. Homework. An equation of AC current is given below. Is given below. It is I equal to 25 sine 300 pi t ampere. Now, question number A. What is magnetic flux? Magnetic flux. Boys and girls, what is magnetic flux? Now, question number B. Question number B. Why? Why self-induction is more effective than mutual induction? Question number C. Find out angular frequency of this AC current. And question number D. If this AC current is connected with 100 ohm resistance, then will it produce 62500 joule per second heat? Explain mathematically. Now, boys and girls, this is your homework. I'm just going to read out this homework that you want to solve this math at your home. An equation of AC current is I equal to 25 sine 300 pi into t ampere. On the basis of this step, we are going to solve the following questions. Question number A. What is called magnetic flux? Question number B. Why self-induction is more effective than mutual induction? Why self-induction is more effective than mutual induction? Now, question number C. Find out angular frequency of this AC current. Boys and girls, find out angular frequency of this AC current. And question number D. If this AC current is connected with 100 ohm resistance, then will it produce 62500 joule per second heat? Explain mathematically. On the basis of my today's lecture, I think you can solve very easily this homework, this creative question. Okay, this is a board question, so solve this board question very sincerely, very effectively. So boys and girls, I know that at your home you can keep studying very well and continue studying at your home, and stay safe at your home. Thank you very much, boys and girls. Thanks for watching my today's lecture. Thank you.